We have three measures of position. Those are quartiles, deciles, and percentiles. Now let's find out what these measures are all about. Let's first discuss about quartiles. In quartiles, the frequency distribution of a set of data is divided equally into four divisions. If we're going to illustrate quartiles, it will look like this. As you can see, our set of data is divided into four equal divisions, so we have 25% of the data in each division. And we have three quartiles. The first quartile or Q sub 1, the median or that is the second quartile, and the third quartile or Q sub 3. Let's first discuss about the first quartile or denoted by Q sub 1. The first quartile is at most 25% of the data are smaller in value and 75% are larger. If we're going to illustrate this, we will have this 25% each division of our data. And again, the first quartile, 25% of the data are smaller and 75% are larger. So Q sub 1 is in between the first half. Now we have the second quartile or denoted by Q sub 2. Now this time, at most 50% of the data are smaller in value and 50% are larger. Let's use the same illustration for quartile. Again, 50% are smaller and 50% are larger. So our second quartile or Q sub 2 is in between or in the middle of our set of data. So Q sub 2 is also the median. Lastly, we have the third quartiles, or denoted by Q sub 3. Again, since we divided our data in four equal parts, we have three quartiles. And the third quartile, at most 75% of the data are smaller in value and 25% are larger. Again, let's use the same illustration for quartile. And our set of data is divided into four equal parts. So our third quartile is 75% smaller and 25% larger. So it is in between the second half of our set of data. That is Q sub 3. Now, how do we locate the quartiles in a set of data? We use this formula. We have Q sub k is equal to k times n plus 1 all over 4, where n is the number of observations and k is the kth quartile, or it can be 1, 2, or 3, since we have three quartiles. Again, we use this formula to locate where a certain quartile falls in a set of data. Under quartile, we also have the interquartile range, or it is the difference between the upper quartile and the lower quartile in a set of data. It measures how spread out the values are in the middle of a set of data. So it is the difference between Q sub 3 and Q sub 1. So the formula for interquartile range is IQR is equal to Q sub 3 minus Q sub 1. Now let's have an example for quartiles. We have to calculate the quartiles and IQR of the following data. We have 3, 13, 11, 11, 5, 4, and 2. Now the given data is an example of an ungrouped data. We have raw scores. Now how do we calculate the quartiles and the interquartile range of a set of data? Our first step is to arrange our scores from lowest to highest. So we will have 2, 3, 4, 5, 11, 11, and 13. Now, we're now going to use our given formula to find our quartiles 1, 2, and 3. Again, we're going to use the formula Q sub k is equal to k times n plus 1 all over 4. We're first going to find Q sub 1, or the first quartile. So we have Q sub 1 is equal to k is equal to 1, since we're trying to find the first quartile, times n is equal to 7, since we have 7 raw scores, plus 1 all over 4. So we have Q sub 1 is equal to 7 plus 1 times 1, that is 8 over 4. Our Q sub 1 is equal to 2. Now that is not the value of our first quartile. Hence, 2 means that is the second observation. So our quartile 1 is equal to 3. Next, let's find Q sub 2. Again, let's use the same formula. Then we will have Q sub 2. Now k is equal to 2. We have 2 times, still we have 7 plus 1 all over 4. Q sub 2 is equal to 16 over 4. So Q sub 2 is equal to 4, or the fourth observation. Q sub 2 is equal to 5. It means that 50% of the data is lower than 5 and 50% is higher than 5. Lastly, we have Q sub 3. Again, same formula, we have Q sub 3 is equal to, now k is equal to 3. Still, we have 7 plus 1 all over 4. So Q sub 3 is equal to 24 over 4, or that is equal to 6. Now, our Q sub 3 is equal to the sixth observation, or that is 11. Now we have located the quartiles in the set of data. Again, our quartile 1 is equal to 3. That means that 25% of the data is lower than 3 and 75% is higher than 3. And our Q sub 2, or the median, is equal to 5, and that means that 50% of the data is lower than 5 and 50% is higher than 5. And our Q sub 3 is equal to 11, and that means that 75% of the data is lower than 11 and 25% of the data is higher than 11. Now we can find our interquartile range, or IQR, is equal to Q sub 3 minus Q sub 1. So we have IQR is equal to 11 minus 3. So our interquartile range for this set of data is equal to 8. So that is how spread out the numbers are in the middle of our set of data. Now let's have the second measure of position, and that is the decile. Now, if in quartiles we divide a set of data into 4 equal divisions, in deciles we divide it into 10 equal divisions. Or if we're going to illustrate it, it will look like this. Each division will have 10% of the data. Since we divided it into 10 equal divisions, we will have 9 deciles. Or we have d sub 1 up to d sub 9. And as you can see, d sub 5 is the median, or Q sub 2. The formula to locate the deciles in a set of data is d sub k is equal to k times n plus 1 all over 10, where again n is the number of observations and k is the kth decile, or it can be equal to 1 to 9, since we have 9 deciles. As you can see, it is just like the formula for quartiles, but this time we have over 10 since we're calculating the deciles. Now let's have the same set of data in locating decile. Say we have to calculate the third decile of the given data. Since we have the same set of data and we have an ungrouped data, our first step is still the same. We have to arrange our set of data from lowest to highest. So again, we have 2, 3, 4, 5, 11, 11, and 13. Now let's use the formula for decile to locate our third decile. Again, we have d sub k is equal to k times n plus 1 all over 10. So we have d sub 3 is equal to k is equal to 3 and n is still equal to 7 plus 1 all over 10. We have d sub 3 is equal to 7 plus 1 that is 8 times 3 that is 24 over 10. So our d sub 3 is the 2.4th observation. Now how can we locate the 2.4th observation? As you can see, that is 2.4, so that is somewhere in between the second and the third observations. Now to locate this, our first step is to get our second observation, which is 3. Now what are we going to do with the 0.4th observation? We're going to add 0.4 times the difference between the third and the second scores. So that is 3 plus 0.4 times 4, that is the third observation, minus 3, that is the second observation. So we have 3 plus 0.4 times 4 minus 3, that is 1. So our d sub 3 is equal to 3.4. That is 3 plus 0.4. Now, since our third decile is equal to 3.4, it means that 30% of the data is lower than 3.4 and 70% of the data is higher than 3.4. Lastly, let's discuss about percentiles, or the third measure of position. Now, if in quartiles we divided a set of data into 4 equal divisions, in deciles into 10 equal divisions, in percentiles we divide a set of data into 100 equal divisions. Or if we're going to illustrate this, it will look like this. If in quartiles, each division is 25% of the data, in deciles, each division is 10% of the data, in percentiles, each division is 1% of the data. So we have 99 percentiles from P sub 1 up to P sub 99. And P sub 50 is also the median. Now, what is the formula to locate the percentiles in a given set of data? We have P sub k is equal to k times n plus 1 all over 100. As you can see, it is just the same as quartiles and deciles, but this time we divide it into 100 equal divisions. So that is over 100. Again, n is still the number of observations, and k is the kth percentile. Or it can be 1 to 99, since we have 99 percentiles. Now let's have the same example for percentile. Given the same set of data, we have to calculate its 20th percentile. Still, our first step for an ungrouped data is to arrange it from lowest to highest. Now we're going to use this formula for percentile to locate our 20th percentile. Again, we have P sub k is equal to k times n plus 1 all over 100. Again, 20th percentile, or that is equal to P sub 20, is equal to k is equal to 20, n is equal to still 7 because we have 7 raw scores plus 1 all over 100. So we have P sub 20 is equal to 7 plus 1, that is 8, times 20, that is 160 over 100. Or P sub 20 is the 1.6th observation. Now again, 1.6 observation is somewhere in between the first and the second scores. Again, let's get our first score since we have 1.6. Our first score is 2. Then we'll add zero point 0.6 times the difference between the second and the first scores. So we have 2 plus 0.6 times the second score is 3 minus the first score is 2. We have 2 plus 0.6 times 3 minus 2, that is 1. So our P sub 20 is equal to 2.6. It means that since we have 20th percentile, 20% of the data is lower than 2.6 and 80% of the data is higher than 2.6.